Here we go. Why is that not working? Okay, let's do it. There we go. Oh, Pete's connected already. G'day, Pete. Excellent. All right.
Hello.
How is everybody?
Yeah, I'm fine. Thank you.
Yeah. Fine, thanks. Okay. Yeah. So, yeah, for the purpose of this meeting is just to discuss further questions for our next report, the planning report. And yeah, Thomas, I've sent you an email attached of the initiation report. Have you received it?
I did receive it. I haven't had a chance to look at it yet. Apologies.
Yeah, that's all right.
We can talk through it if you like.
Yeah, it's basically a report that outlines the overview of the report, why we are doing it, and the stakeholders and what we will deliver you to by the end of the project.
Yep.
And yeah, and we did some stakeholders and risk analysis as well. Yeah, just take a skim at it after this meeting if you would like to talk about it later on. That's all right.
Okay.
Yeah, so the first thing I want to talk about is after we have discussed internally, we would want to get the data into SQL as we have mentioned before. And you've mentioned that it was done beforehand as well, right?
So all I mentioned before is that we tried to build some kind of like database approach and it didn't work.
Yeah.
It ended up being larger than the data. So
Yeah.
it kind of didn't make any sense.
Yeah.
Right. So should if we want to get this into SQL regardless, would there be any help from like the TPAC team, like technical?
So I think the important part to think about here is getting it into SQL actually a useful exercise in any way, and if and that's one of the reasons why I'm excited that Pete is joining us for this meeting. Pete's my colleague. He's our technical expert, and I'd strongly recommend that you put any of these questions to Pete first. Pete has a whole bunch of things he's tried in the past and knows what does and doesn't work.
Yeah.
And so I'd yeah. So in that, so I guess Pete, have you had a thought about that at all?
Not really. I'm still a little bit unclear about the exact direction of the and objectives of the project because I haven't had a chance to read through that document since the first draft of it a little while ago.
Yeah.
But I guess when we're talking about making putting the data into SQL, I assume you're just talking about the metadata.
All right.
Is that correct?
That could be one approach, but yeah, because it's such a large amount of data, don't know if it'll work so great in SQL. But it would be like, because we don't have any experience with interfacing with these NetCDF files or anything, we'd be able to develop much easier if it was all in SQL. But yeah, it is a concern if it would work well in that format. Yeah,
it'd certainly be it would be an unusual approach to try and put all of the data into SQL. I'm not sure that would be.
I wouldn't. I was only ever expecting the metadata to be sitting inside that.
Right. That's
when I had any discussions about it, because I don't think it's possible to store the data efficiently inside SQL.
Yeah.
And it was even just the metadata itself ended up being too large in the SQL approach that we tried to build.
Okay.
And the reason for that was because we wanted to be able to, if you remember when I gave the presentation, when I gave the initial discussion to you guys, I talked about how if you're an elephant seal swimming through time and space, we wanted to be able to trace all of those data points and be able to extract them out in a single point. So that's like That's the gold standard approach of how we want to extract data. In order to do that, every single data point needs to have metadata associated with it, so that we know where it is in space and time and what variable it is. And when you build something like that, well, the way we built it, the metadata database ended up being incredibly large.
Yeah.
And so we thought, well, maybe you guys have experience with building these things and understand how you could maybe circumvent some of those approaches where we might have been saving stuff like, you know, a million times and we only have to save it once.
Yeah.
So that was kind of what I was thinking in that context. But it would only be saying, if you're a data point in this location, then we know it's in this file over here and it's at that location there. So
Yeah.
that was really kind of how I thought that might work.
Yeah, that sounds reasonable.
And so that's where I thought, well, maybe SQL is a solution for us to build up our kind of data discovery element of like what data exists where and how to go get it, but not necessarily like how we store the data.
Yeah.
Because I find it difficult to believe we could find it more efficient than what we've currently got it at. Do you agree, Pete?
Yeah, although it comes back to some of the questions that we were talking about the other day with Eratos about actual file structure for making it efficient to extract individual or service individual queries and that sort of thing. But as far as leaving it in NetCDF format, I think it's the only practical solution, given the needs of the combined, you know, external users and our own use. So, but definitely, I guess starting from a minimalist approach, you know, the bare bones as far as building a database and then building it up to see how much functionality we can get out of it, would be the, you know, I think the way to go. At least for the, you know, I can't imagine that there'd be any sort of problem in using SQL to do something like just build a searchable database of the, like a catalog of the data holdings, as a first sort of step towards building the rest of it all on, you know, building the rest of the system on top. Am I sort of going in the right direction here?
Yeah, I think we're definitely going to need some sort of metadata database. So when we find out that we need, I don't know, rainfall from 2016, we have a SQL database that shows us or tells us where those files are, so we don't have to go find them.
Yeah.
Yeah. And I think that could be made like with a script because of the directory structure you guys already have, I'm guessing.
Yeah.
So you guys have tried this before.
I wasn't involved in that personally, but
okay.
So I'm not sure exactly what it was. You and Dino, is that right, Tom?
That's right. We spent a bit of time and failed. So
it's a good omen.
Yep.
But I get experts.
That's right, exactly. And the other part of it, I guess, too, Pete, is I'm wondering as to like I don't have enough experience with SQL to know whether that's a more efficient approach than using the Threads server or using one of these other pre-existing tools.
Well, things like Threads is, I mean, they call it a catalog, but you're just browsing a directory structure. It's not, and so, you know, it's not really a searchable catalog.
Okay, all right. That's where.
So that's where something like what we're proposing here would be a definite advantage.
Yeah. Okay.
Yeah.
Is Threads something you guys are already using?
It is. We have some of our data, well, some of the historical data, I guess, that we don't use so much anymore, available through Threads. But it's certainly not. It's not something we use on a day-to-day basis, and there's very low external usage for the Thread servers we do have established, and they're not certainly equipped with the full functionality to make the best use out of them. So whether we use that whether that's part of the solution going forward is still an open question. It'd probably be useful, something to consider as part of that. But it doesn't have to be like integral to the system, I don't think. It's just something that we have multiple access methods for the data running concurrently. But I don't know how it would be part of a system that you guys would be developing. It's an interesting question.
Yeah.
So Pete, could they use the Eratos stuff?
In principle, I suppose so. But yeah,
I know there's it's messy, but I was just wondering if that was a potential option.
I guess that's more a question to ask Eratos as to whether they would, be willing to make it available, given it's all beta at the moment. So,
yep.
I think it'd be a tricky thing. That's a difficult stage of development because these guys would have to be learning a new tool, which itself is evolving constantly.
Yeah. Okay. So let's not worry about that for the time being then.
I think let's consider that like an alternative, and pursue this as a independent sort of solution.
Yep.
Yeah. Yeah. So, Thomas, in the last meeting, you mentioned about data models, and there were 6 of them, if I'm not wrong. Yeah. Could you give us like any brief explanation about what they are, and if there were any documents, it would be better if you could give us those documents.
Okay. So do you mean about the fact that we have? So I think you're talking about the fact that there are different global climate models. Is that what you mean?
I think that was like a way of how you are organizing the data in the system, if I'm not wrong. Like, those were data models.
So is there somewhere where you reference that in the document that I'm looking through the client from the last meeting, because I'm not really on the same page as to what you're talking about.
Yeah, we didn't mention that because it was like a query that we had to solve. That was a report that we put on things that we have already known. So yeah, it would be any part of it inside the initiation report.
Right. So, well, I don't really understand the question. If we've got 6 models, for example, if I was going to talk about 6 models, the way you could think about that is they are 6 variables. So you could think about them as just being as different as temperature is to rainfall is to humidity, and they're different data layers, and we need to be able to see them. And that's when I think what I would have mentioned in terms of there being 6 data models. That's what I would have expected I was talking about.
Yeah, so like there are 6 large variables, and each one of them has smaller categorized variables that are related to them.
Yes.
Yeah, right. Okay.
Yep. And in the so when I sent the path names through of the directory structures that we're dealing with, the global climate model was there's 6 of those if you're looking at that directory path. And that's in this one, I think it would have been Cyro-bomb-access 1.0, something like that is the name of one of them. They've got horrible names.
So in relation to the application, how do these data models affect like how we serve the data?
So I don't think it's useful to call them data models.
Yep.
They're global climate models. So it's actually, there are lots of different assumptions that you make when you run a global climate model. And they get kind of positioned inside, okay, here's all of these assumptions, and we're going to call this one access one. And then here's a whole bunch of other assumptions, and we're going to call that GFDL, which is geophysics lab, NASA's geophysics lab. They've developed the global climate model. They have a whole bunch of different assumptions. There's 56 of them or 100. They're growing every day. All these different ways of assuming how the global climate works. And that means that we get different estimates on what the future is going to look like following different assumptions. We currently have access to output from 6 of them. And so it's like, so the way the directory structures, and I'm going to have to think this through, it's coming, I don't have it in front of me, is we have the time step. So let's say the decade at the bottom. So let's say it's 2000 to 2010. Then the next step up is the variable. So then we might be looking at temperature. Then we're looking at whether it's daily or monthly summaries. Hourly, daily, or monthly summaries, I think, is the next thing. Then it goes to what version of the model it is, and what version of the regional climate model that was used, then what version of the global climate model that was used, and then the global climate model. So in the kind of hierarchy, it's just a piece of metadata, effectively. If you're looking at columns of data, it would be like global climate model at the top. And for this whole big chunk of data that has lots of different things in it, all of it has one value, which is access one.
Okay.
Does that make sense? It's
Yeah.
hard across this using this.
It's a little bit confusing, yeah, but yeah.
How about I try something different? Pete, can you try and explain it while I try and pull up our actual
Yeah, so
our actual workspace, and I can kind of talk them through it, because these guys are computing guys. That's talking to them through a directory path will probably make more sense.
yeah, good idea. But to sort of illustrate perhaps the sorts of the way it would impact or the sort of consideration you would need for dealing with different queries. One user might be interested in just looking at the data associated with a single global climate model, and say multiple variables across different time periods just from looking at a single model, whereas other users might want to look at a specific parameter like temperature or something, but look at the comparison of that parameter, look at the comparison of temperature projections across the 6 different models. So the sort of the directory structure associated with the data as far as individual variables goes will be replicated exactly sort of 6 times. In that there will be 6 sort of directories somewhere in the directory structure that correspond to 6 different global models, and then within those 6 directories, the subdirectory structure will all be exactly the same. And Tom is working on illustrating that now through, I guess he's going to share the screen, and we can look at just step through the shell or whatever interface he's going to work through. Does that sort of make a little bit of sense?
Yeah. So does that mean there's multiple models for the same data?
No. I guess each model will have been run in the same way and produce the same variables as output, but they will all be independent. So it's just that each model will have a set of say temperature projections, projection data that'll have the same dimensions, both in space and time. And so they'll be exactly the same format, but the actual individual data points will all be slightly different.
Okay.
So Tom, sharing your screen.
Are you currently muted, Tom, just in case you've forgotten?
There we go. Okay. How about that? Thank you. All right. So can you guys see my screen
Yeah.
in a
Yep.
reasonable way? So I've started here. So here you can see the path that we're traveling. Can you see my cursor?
Yeah.
Okay, cool.
Yeah.
So this is saying it's the research data storage infrastructure. And then
Mhm.
inside that we have these are basically just all like paths to our project's home. Okay. And then inside this output one is where it starts to be like the real business end of what you need to care about. Here we have different domains. So the Australian 50-kilometer domain, for example, it covers Australasia. It goes from basically southern Africa all the way up to the Coral Sea. Covers all of Australia. That's how big the sort of spatial domain is. The Queensland, don't worry about those ones. Then we've got Southeast Australia 10-kilometer domain. That's now this goes from just west of Adelaide up to the Gold Coast and down to Tasmania, down to the southern tip of Victoria. The Tasmanian domain just covers off Tasmania, and the Victorian domain just covers off just on the boundaries of the Victorian state. The 5 indicates Vic 5 means that it's at 5-kilometer resolution. Tas 10 means that it's 10 kilometers resolution. C10 means that it's at 10 kilometers resolution, and 50 means that it's at 50 kilometers resolution. So if we click into any one of these, so I'll go into the Tasmanian one, and I think if we just focus on making Tasmania work for the start as like the minimum viable product, it's relevant for what we're doing in a lot of other of our projects, and it should be relatively easy to scale this up once you've got this bit working. So this says, okay, the data was delivered to us by CSIRO. We now have the 6 global climate models, okay? And we've got 6 global climate models, and CSIRO BOM AGCD is actually observational data. So we treat that as a separate model, but it's actually the stuff we use to validate everything else. And it's arranged and designed as if it's just another model, so we can feed it into our systems seamlessly. So then this one here, this is the one that Australia's global climate model is called Access. And so we can go in here. Here we have 2 different experiments. One is the experiment that tries to simulate historical climate using the carbon dioxide concentrations that have been observed over the last 200 years. Then we have what's called representative concentration pathways, 8.5 watts per square meter. So RCP 8.5 means that if the atmosphere gets a certain amount of greenhouse gases in it, it will absorb 8.5 watts per square meter of energy from the sun. And that's the experiment that this is testing. There are lots of others, but this is that's all you need to really understand. Is one is historical climate, and the other is the going into the future. So if we go into historical first, and this, that's right. So have a look up the top to see where the path goes. So this is the regional climate model we used. It's CSIRO's CCAM model, and it was version R3355. And then we have hourly data, daily data, monthly data, and fixed data as in data that doesn't change. It's sort of a set configuration of the model. We'll go into the monthly stuff just because it's smaller. Then we have all of the different variables that have been output from the model. It's about 100 there. Let's go into ones we can actually understand. We've got so maximum temperature. So this is temperature at surface, daily maximum. So, and in here, let's make that a bit bigger. We have the actual files. And so one of these files has almost all of that information held within its file name. This is following a convention that's from the Cortex community. You don't need to understand that right now, but that's where it comes from. And you can see it goes from 1960 in decadal files up until 2005. And then that's where when they ran these models, 2005 was sort of close to the data that everyone agreed on for carbon dioxide concentrations. It takes some years for everyone to agree on what the actual carbon dioxide concentration is. And so they chose that as the end point. And then 2006 onwards is all projected from the model. It's not real. It's not the pathway of carbon dioxide is estimated or set following a socioeconomic model. It gets complicated really quickly. I have not described that very well. I apologize. I'm not feeling well at the moment. So these files. So is that helping at the moment?
It's helping, yeah, a bit.
Yeah, probably.
Okay, so have any of you successfully had a look at the example files I sent through using Panapply?
Yeah.
Okay, so do you understand the format of the NetCDF files and what you're kind of looking at?
Sort of like we kind of understand what data goes into them, but not like how the format itself is structured.
Yeah.
Yeah. Okay. So you've got to think about it as like data cubes. And let's see. Do you reckon it might be useful to show them an NC dump, Pete?
Yep.
Okay. So if I go to that file, oh man, now I have to remember how to get around my own directories, guys, while I'm being watched by everyone. Let's try that. Yeah, that's right. Oh, look! Finally, I've caught up to where it is above. Okay, there's that, and then let's go to a monthly file of Tasmax, and then Tasmax monthly. And I think let's look at 2000. Okay, so all right. So inside this file, if we start from the top, we have a grid that is 71 values across the longitude, 49 values up and down across the latitude, and there's 72 time steps. This is arranged such that they have variables, and the variables have dimensions and attributes. Longitude has the variable name is lon, but it has a long name. It has a standard name that's understood by a lot of other programs and a lot of other naming conventions. It has the units along which it's actually put along, and it has a direction. So if you think that inside any file, you have kind of like either a single dimensional, just a string of numbers, or you could have a grid. And if you've got a grid, then you've got an X and a Y dimension, or a rows and columns kind of thing. And then if you've got a cube, you've got rows, columns, and then layers that sit behind that.
Yeah.
And then you might have rows, columns, layers, and then you've got groups of cubes. So all of those cubes move through time, for example. This particular version, let's ignore the bands for the time being. Don't worry about that. This version has three dimensions inside this file. It's got longitude, latitude, and time. So we've got rows, columns, and layers is the way I like to think about it. And the first two are relatively straightforward to understand. If it means that if you're in position 71, for example, of longitude, we know what your longitude is because we only have to save that value once, because everything that's sitting inside that position on the grid will have a value of 71. Does that make sense? The 71st row.
Yep.
and then we've got columns is latitude. Now there are certain ways that you can save this data so that it's more efficient to get that data back later. So you might decide that actually it's faster for us to get data back if we made latitude the X dimension and longitude the Y dimension. And that's kind of a lot of stuff that Pete was alluding to earlier in terms of efficiency. But that's what this is starting to delve into, that stuff in terms of the actual data model of how these files work. So that's X and Y done. Then we've got time. Time has, it's got a standard name. It's got other attributes attached to it. Time, basically time sucks. It's just so complicated. It's annoying. All you want it to do is step forward, but then it depends on where's your origin? Are you starting from the year 2000 or are you starting from the year 1900 or all those kinds of things? Are you using leap years and leap minutes? All those kinds of things need to be considered when you start talking about time, and it's very annoying. In this particular group, we have a standard calendar. So this means it does have leap years and does have leap days, does have leap minutes, does have leap seconds. All that stuff is built into this system. It's considered the t-axis because it's not a height, which would be considered the z-axis. It's the time axis. Inside this, we then have an actual variable that's full of data. And this variable sits inside the dimensions time, latitude, and longitude. So then the value that you would see at position 71, 49, and 72 would be the last value in the entire cube, and it would be it should be in December 2006, and it'll be in the bottom left-hand corner of the grid. So you've now got these variables describe the dimensions that TasMax actually sits within. And we could have many different variables sitting inside those same dimensions. So NetZDF is an incredibly flexible data format. And at the moment, it's being used in a very simplistic way in some ways, because we're just putting in the bare minimum required to save this particular variable and all of the information we need about it. So then you go through, so this particular variable TasMax here has lots of attributes. These global attributes, though, apply to every variable inside the format, not just to TasMax. It applies to time and latitude and other stuff as well. And it gives us information about who created the data, what version they used, what tools they used to build it, what some of the broad kind of domain descriptions are here, who to contact if you need more help. All these, you can add a whole bunch of metadata into these files very efficiently, and it only saves it once, and it's easy to find and extract later on using the various tools. So this is just the metadata. If I opened up the actual raw file, it would be a bit trickier. So what I'm going to do is
Tom, maybe you could just do a -C. NT
Okay.
-C.
Okay. Oops. So now you can, so we've gone through all the header data information, which it's repeated here. And now we're looking at actual values of each one of these variables. So longitude, latitude, and time are all dimension variables, and they're telling us what the values are for each position in the grid along that particular dimension. So we've got from 143 to 150, which you'll note actually also corresponds to these values here. Similarly, for latitude, it goes from -44 to -39.2, and again, that's reflected there. Time, as I said, horrible working with time. This is a POSIX value, or it's actually a minutes from, isn't it? Here we go. We look
Hours
up.
from.
Yep, go up and have a look. Days from.
Sorry,
there we go.
Pardon me. Days from. It's monthly, isn't it?
So this is days since 2001. So this is 15.5 days since then. And then that goes up to 2,176. So this is useful. I'm surprised they have it's saved as a decimal, because it's often used as a integer value, because you can count, 1 day since, 2 days since, etc. And you don't need to have the floating figure of the decimal point. That's more of a computing side of things. I'm not sure how much you guys have talked about integers and floats and characters and stuff in what you do, or have done in your learning so far. So that's one example. Peter, is there a way I can just get a tiny bit of the TASMAX data with -C or
NC dump?
NC dump into like maybe a less or something? Let's try that. Oh, what did I just do? There we go.
You could do it. You could pipe it into a tail -n.
I'll try that. There we go. That's good.
Oh yeah.
Okay, so that gives us the longitude, latitude, and time that we discussed. Time bands, I'm not going to worry about. You guys don't need to know that right now. And then we actually get to the actual values that we're interested in, TASMAX. So this is how it's stored. It's just stored as a single long list, effectively, of numbers, but the position in the list tells you which row, column, and time step you're in. Does that make sense? I know you guys.
So
Go
the
ahead.
first value is that like the first lat, long, and time,
Yes,
That's right.
and
Well
what
done.
the second value is the second lat, but the first long, first time.
That kind of thing, exactly.
Okay.
Yep, and you've got
Based
it.
on
And
the order that the dimensions are listed in the header information for that variable.
Yeah.
so if we go up, we can say, all right, so everything's time first, and it's going to be the first latitude and first longitude for the entire time. All is it all times in that context, Pete, or is it latitude, longitude?
I think it's sort of listed in reverse in that.
Yep.
In this instance, so what it'll do when it's writing the data disk is it'll write a whole row of longitudes, then go to the next latitude, write the whole row of that longitude to that latitude. Sorry, the whole lot of temperature values, and so forth. So it'll do it in stripes, doing the first latitude row, going across longitude, and then once it's done a whole, all of the first time step, writing all of the temperature values for each lat and long, then it'll start again for the second time step, beginning with the first longitude at the first latitude band. So
Okay.
So Joel, in the language you said before, and we go back here, this value here would be the first latitude, longitude, time. The second one would be the second latitude, the
second longitude,
first latitude, first time.
Yep.
So you had exactly the right concept, but you can actually see exactly what you should be doing by looking at what's in the header information.
Yep.
So
you don't need to understand in great depth how it's written, how it's stored on disk beyond that. The NetCDF API is that there's no need to, it's very functional and quite low level, so you don't need to worry about actually reading the format. There are tools already written for you to do that. So
Yeah.
It's useful to understand it, but you don't necessarily need to know how to drive it, because you're not creating these files.
Yep.
So just looking at them, and you have to be able to extract those pieces of information out, because they're all kind of useful.
But we will be creating these files eventually to serve the data, right?
If you're, potentially if you're going to be serving subsets or process data, then yes.
Yeah.
That would be the case.
But the API has like functions for that.
Yep.
Yes, that's right. Because all this data is this metadata, particularly this header stuff here, because that's all kind of standard for each file, it can get carried through. The problem would be when we need to find out that some of it changes between files.
Yeah.
So for example, the days since number, if we stack a whole bunch of top files together, we need to make sure that it's actually using the correct days since and it's adding them all up to correctly. But we will be here to help you with that, and in terms of that final delivery step. But it's worth understanding what this looks like. And at present, a minimum viable product would be delivering more of the actual files themselves, and then we start going into the subsetting as the project progresses.
Okay. So you want to just serve these files. Okay. So what if they want multiple of them? Do they want them like a zip?
Just in terms of getting everything kind of sorted, the first step is actually like, what files do we have?
Yep.
What information do we have stored within them? How can users navigate that and select what they need? And then we'd worry about an extract step that would a data sort of subsetting or extraction step that came after that. And there are tools that are off the shelf that can do that for you. So you don't have to worry about it as such.
Okay.
You're not having to understand how to create those files yourself necessarily.
Yep. Okay.
Yeah. I have a question regarding this part as well.
Mm-hmm.
How exactly our potential users are going to like use the data? Like, would you have to explain to them like you just did to us in order for them to use it? How do they utilize this data?
So some people will want to get points out, single location, all time steps. Some people will want to get single location, but only for a subset of time. So they might only want from 2030 to 2060. Some people will want to have some people want to have monthly values, like what we're looking at here. Other people might want to have hourly values. So that they'll need to be able to extract it on that, like that concept. Some people want to have everything and download everything. In that, I think we'd basically be telling them that they should be talking to us about an alternative access point if that's what they want, though. So I think we kind of need to probably make that not possible. Some people will want to have a very specific space. So if you remember when I was drawing on the board, if you've got a local government area, you have a polygon that you've drawn onto a map. Well, that would be sort of similar to saying, let's assume that this Tasmax that we've got here is actually a grid of latitude and longitude, and they only want like that bit there. So then some people will want many values, but not all of the values. So they want to really be able to subset it down.
Yeah.
And that's where you could just subset based on a rectangle, and then that'll be close enough to what they want.
Yeah.
And then the ultimate is being able to say, this is where my elephant seal swam. Can you please give me all of the values of where they swam through this particular data set through time and space? So everything's changing in every single location and needs to be extracted individually.
Yep.
That's the most complicated solution. And that's what we'll get to after we've done many other viable products.
Yep.
So that takes me to the next set of questions as well. These are questions about how do you manage these users like in a daily basis. Like how many requests do you have like for a week? Do you get them usually from users?
So do I still need to have this open, do you reckon, sharing my screen?
Oh, no. Not currently.
No.
Okay.
So we're going back to like questions about like the project itself, not so much technical.
Yep.
Like when people request data from you, so how many of those requests would you say you get a week?
What do you reckon, Pete? Like 1 or 2 a week in terms of being able to provide people access? You're muted.
Sorry. That was a mistake. Well, it's hard to say, isn't it? I mean, I don't know if I haven't checked what the usage stats on the threads servers are, so I don't know. But it's I would say it's less than 1 per week.
And then it's also a matter of how many people want the data but just can't get access to it at all. They can't find it online. They can't find out they need to talk to us about it. So I think this is actually going to be about making data discoverable and therefore increasing the number of people that ask for help.
Yeah.
But then also automating the process of them actually extracting data for themselves.
So at the moment, yeah, it's very low, but we anticipate that providing this service will increase increase the volume of traffic, both ways, considerably, and probably consistently for a while. That it'll ramp up once people actually realise that the data is available and accessible, and word starts to get around.
Yeah. So, I guess we'll just say 1 a week for that.
Yeah.
I certainly get requests at least that rate, and I'm able to service about 5 a year.
Yeah, because you mentioned when someone contacts you, you have to converse quite a bit to actually figure out what they actually want.
That's right.
And so I guess that takes up a lot of your time. So we're looking for now, like how much time actually comes out of your schedule to service one of these requests?
So that was I'm actually looking at that page now. So I said that I probably spend about 1 to 2 hours a week at the moment managing people accessing data.
Yep.
It usually comes around as like I have to spend like 2 days at any one, like 2 days kind of solid delivering stuff and helping somebody with something. So, but then it kind of that's interspersed over long periods of time.
Yep.
And so, and some of that's also training people on how to access the data and all that as well. So there's quite a lot involved in that.
It's sort of complicated in terms of how it relates to the present project, because sometimes that'll be people aren't requesting just the basic data, and they want analyzed data, or they want to do the analysis. And so yes, it's either handing them the data, or more often like Tom was saying, training them to use the tools that are available on one of our virtual machines to be able to interactively work with the data themselves, which is where having the tools available in a web portal to do that themselves in a more manageable way would be a great way of saving our time.
And also allowing them to understand where they need help, and therefore actually paying us for our time. So, because when they go in and try and do it themselves and go, wow, this is hard, then they go, maybe we need help. So it's really about giving them as much autonomy as possible, to the point where they actually realize that they need experts and they need to fund experts to help them as another part of that.
Yeah. These users, are they usually researchers or businessmen?
Both.
There's
an increasing interest from the business sector.
Okay.
But I'd say most of them are researchers.
Yeah.
Yeah.
And I think in some ways the people that we're most interested in helping at the moment with this portal is researchers.
Yeah. Yeah. We wrote about that in the initiation report. The priority users are the researchers.
For us at the moment.
Yeah, at the moment there's like a first attention thing.
Yep.
And what's the average amount of size, like, of the data that you give? Do you often give like a gigabyte or a couple megs?
Pete, what do you normally hand out?
Like per requester?
the volume going out is often a lot smaller than the amount of data that needs to be processed to do so. I mean, yeah, it's not usually handing out the sort of stuff that I've done is rarely handing out just the raw data. It's normally processing a large volume of data into a small sort of collated statistics and handing that out, which would be of the order of I don't know, 100 megabytes or less.
Yep.
But processing tens of gigabytes to get that, possibly hundreds.
Yeah, okay. Yeah, we haven't taken into account like processing time at all yet, so we'll worry about that.
Let's put that at sort of more the other end of the spectrum as well. So the first step is to just be able to deliver stuff out.
Yep.
The next step after that is, and how could we build in a whole bunch of like processing tools that exist?
Yeah.
So, and there are tools out there that do these tasks already that Pete has found. One that I'd strongly recommend you look into is the Climate for Impact portal that is available online. Have a look at what they've got there, see if there's any instructions on how to implement that on a standalone server for your team. As in, if you're a research team and you want to install and manage that, so I'd strongly have a look at that as an alternative implementation plan. Those tools are also familiar with looking at climate data, so they might have built in a lot of these things that you're struggling to understand. It might automatically do it.
Yeah.
And so would you agree, Pete, that that'd be a pretty good strategy?
Yeah, I still don't know what the requirements are for, academically are for fulfilling this this project, but certainly that's the sort of it's exactly the sort of service that we'd like to have implemented, although it doesn't it certainly doesn't cover this full range of functionality that we'd like to have available. So if it was something that could be implemented and developed further to achieve our specific objectives, then sure, absolutely, it'd be fantastic.
Yeah. So our understanding at the moment is that the people who use this database the most are you guys in the Climate Futures team. Yeah. Like, are you working with this data like all day, every day, or?
Yes.
Yeah. Okay. So
and these tools will be useful to us.
Yeah.
Let alone to who we actually have in mind as our next users or end users.
Yeah, for sure. So we made like a little survey, and it would be great if you guys in the Climate Futures team could fill that out. And if you could also send it to like anyone that has requested data from you in the past. So we're just trying to get some information so we can write about the users and stuff for our class. So yeah, if we could get like 20 survey fill outs, that'd be great. This gives us some things to write about in our next report.
Yep, I'll send it out.
Cool, great, thanks. Yeah, we'll get that survey link to you after this meeting.
Yeah.
So yeah, we just we need a document or an email or something just saying like, or maybe just access to the directory structure that you've got, because we don't have access yet.
Oh yes, apologies for that.
That's alright. I'd like to know like what all the variables are, because there's like 100 variables there and we don't know what any of them mean. Like TASMAX, I've already forgotten what that means. So if we had like a document that explains all those abbreviations and what they actually mean.
Yep, no worries. It'd be great if you could send an email saying here are all the things that are still missing that we need to know, just to prompt me. But I will make sure that I make a note here. So I'll send an email to Dino Pete, who has he has a metadata list. saved away somewhere. Do you know where it is, Pete?
No, not off the top of my head.
Yeah, so we're not going to search for it here. And I also need to set you up a Nectar instance. I have mentioned you guys to our contact at the in TPAC, Joost Burkout. He is excited about getting this started. So, and he can see enormous advantages with liaising with you guys to make everything work. So, yeah, get in touch with him. I'll try and. I'm not sure if I've already sent an e-invite, but I'll try that again. And that would be so when I was going to set up a Nectar instance for you, and the day that we were actually having the meeting last time, the whole Nectar system was down due to a fire that they had. So that's since been resolved, and everything's back online. But everything was out for like 3 or 4 days after that. Yeah.
Okay.
So yeah. So that's why I didn't do it straight away, and then it kind of dropped off my list, unfortunately, because everything else went crazy. So I'll try and get onto that in the next day or so to get a Nectar instance that you guys can use. I'll talk to Pete and to Joost about what kind of resources you'll need.
Yep, and just with read access to the data structure, database, so would be good. We only need read, yeah.
Yep. So I wouldn't call it a database. I'd call it just a data storage. It's just a direct. It's just effectively a massive hard drive.
Yeah, I just don't know what to call it.
Yep. And I'd say you guys are going to help us build a database, which is like a queryable, sort of searchable kind of space, whereas all this data just kind of sits in a massive hard drive, which is somewhat useful, but not exactly a database as such.
Yeah. Yep. Yeah. Well, that's
the data store.
Yeah. Yeah, that's the great thing about SQL, because you can just write a query like I want this data from here, but this data just kind of doesn't work with SQL, so it's really tricky. I'm not sure if there's something that you climate researchers around the world have a standard for, or I guess not.
There sort of is a sort of global network of data stores that contain climate model data that does have its own sort of searchable catalog, but I wouldn't say it's like a standard as such. That's the Earth System Grid Federation, which all of the data that's used to make the IPCC assessment reports. The sort of system that's used in that context, but and that might be worth looking into in terms of how to go about building a catalog or a database in the present context. And I guess we could point you to the links. That whole system is open source.
But the other part to think about, though, is that even those systems, typically the way they work is it's where is the file is what the database does.
Yeah.
And then it gives you a list of files. It doesn't give you the data.
Yeah.
And so, and if you look into this and it's like that's actually all you'll be able to achieve by the end of the year, that's also fine because we still don't have that.
Yeah.
So thinking about it in terms of really like minimum viable products, like what are the things we really need to be able to do? Delivering people files is the minimum viable product.
Yeah.
So, and if that just means that there's a simple database that says, here are the path names attached to this metadata, you can search on the metadata and it gives you the path names, that would be great.
searchable by things like variable and time period and that sort of stuff.
Yep. So and that's not a big ask, and there's lots of tools out there that can do it, and you could probably build your own bespoke one if you wanted. So that's that's all possible. It's really about, okay, once we have that, what kinds of technology what types of solutions do we need to take it to being able to do a subsettable version and all that kind of stuff. And again, there are tools that exist that we can look into for that as well.
Yeah.
So just to make sure that it does seem big and really hard, it's like it doesn't actually need to be, and we're happy to work with you guys to deliver what it is you can achieve. I want it to do everything, and I think you guys can get there. And it's and some of these things are really hard to get your head around, but once you've done it, it's like, aha, okay, we can do stuff.
Yep.
But it does take a little bit, and unfortunately, the Zoom meetings we might have to have a think about exactly how Pete and I can deliver effectively some training into what some of this stuff is, if you guys can articulate your conceptual challenges to us.
Yeah. Quick question about those netcdf files, because each one had the metadata and stuff. Does every single netcdf file have latitude, longitude, and time?
In our
in your data store.
Yes.
Because it's all related to climate data.
That's right.
Yeah. Yes, it does.
Yeah. Okay. So we'll just assume
we'll
we wouldn't have that in the data. If we create a metadata database, we would just assume that every single netcdf file has latitude, longitude, and time in it.
Yes.
Yeah,
the latitude and longitude might change.
Yeah.
But they will all exist.
Yep. Sure. Okay. All right. I'm just going back to the question document. You mentioned in the very first time we met you, when you did that presentation in front of the lecture, something about the UTAS research data portal.
Yep.
What is that? Because we googled it and there's not much information.
I know, it's rubbish, isn't it? So it's brand new. Basically, what it's designed to do is to provide researchers with a space to put data that doesn't necessarily fit inside a national repository. It's then also going to be that's its core function.
Okay.
So you can feed out data to the world that doesn't have a natural other home other than inside the university. Then our data kind of sits in a different space to that. However, we don't have anywhere else to put it. So the research data portal, all we need to do is actually link in a certain amount of metadata, and it will be able to say this is searchable through this alternative web portal.
Yep.
So it's not. So Yoast has been tasked with trying to figure out how to get our data into the research data portal in a sensible way. The way I see that in the smallest, easiest task, it would be metadata inside the portal, and that's it. And I'm not sure if that data portal has capability to do anything past that, except for so it's like somebody's gone out and collected a whole bunch of surveys. They've got an Excel spreadsheet that has data that they want to share with the rest of the world in it. So the data's tiny. It's a single file. The metadata is often bigger than the actual file itself, but it's about making it findable. Our data doesn't really fit that kind of use case, but it certainly makes sense for our data to be mentioned and recorded inside the research data portal.
Sure.
So it's about understanding what do they need from us, and Yoast has actually been tasked with trying to get that done. So this process to be able to intersect with what he's trying to achieve will be really helpful. And also, Christie's mentioned that getting access to the research data portal or centralized UTAS systems is tricky.
Yep.
Well, Yoast actually has been asked to do this task. So you might be able to produce stuff that then he he does that bit for us.
Okay. Yep.
So, but it also doesn't have to be part of the project as well, right? So
Yep.
if we find out that it either Yoast doesn't have time and energy to be able to help, or there's all these like security issues that ITS bring up, we're just like, yeah, right, whatever. We're not going to bother with that.
Sure. Yep.
We'll ignore the security issues over here. So yeah, so so in terms of where does that fit, that's where it fits.
Okay. Cool. Yep. So that's like kind of a low priority thing near the end of the year to look into.
I think it would be good to tie it in much earlier to see if there is something like that it solves. Like it could be the research data portal has some tools that are really helpful. But it's about managing that through Yoast and making sure that it doesn't gobble up heaps of your time for no impact. But just, but that's where it fits. Yeah.
Okay.
Do you mention this you make a survey?
Did I mention the survey?
Yeah, Joey mentioned it. Survey already.
Yeah.
Yeah.
I think Tony's connection is a little bit dodgy. You mentioned earlier. I think we're all good for now. Yeah, so we'll send through an email just to remind about like the Nectar Cloud instance credentials and about the Nectar Cloud instance credentials and the directory structure access stuff. But I think for the moment we've got all the information we need to go ahead. Does everyone agree? If they're not muted. Yep. Okay, cool. Well, thanks, Tom. You're muted, just so you know.
Yep, I know I'm muted.
Thanks for meeting. Yep, all good. Thanks for meeting with us, and we'll get to you real soon with an email and that survey and everything.
Okay, that's great. Pete,
Yep.
Did you have any other questions or anything else you wanted to bring up with the team?
I don't think so.
Thanks for also coming, Pete. It's great to have two of you.
It's great to have this project underway.
Yeah.
Oh yeah, we're really excited about it, and honestly, to be able to deliver something we're happy with should be very easy.
Okay.
And we have very low expectations in terms of what we need. Low demands.
Yep.
High expectations. We think you're a really strong team, and we think you can actually deliver something that'll be really awesome and quite amazing.
Yep.
And if it works, it could be something that actually gets picked up and used nationally. There's a lot of stuff happening in this space at the moment. Certainly, it'll be a good thing to put into your portfolio for lots of opportunities to work with people in this space moving forward. There's going to be a growing demand in this space internationally. So, we're really excited about it. So,
yeah, we are too. Everybody. Yeah, we just really want to get a good product out there for you. So, thanks for the meeting, and we'll get to you soon.
And so nudge us, like ask us for stuff.
Yep.
Please. I can't remember if it was this project or the other project I'm associated with, but if you have deadlines for your for submitting stuff for the class, I'm going to need like probably 3 days notice to be able to respond.
Yep.
So if you want something from me, don't expect any feedback for 3 days. And then you need to incorporate it into your results. So, I'm not gonna, and I won't be responding to stuff like at after 5 or before 9. So, think about in terms of when you're engaging with people and managing clients, you've got to think about when are they actually at work and what are they doing and what timelines, what competing things do they have on.
Yep. And
so providing people with enough time to respond is important. So I thought I'd provide that as feedback for an email I got. I think you said it's due tomorrow. Can you please answer these questions? And I actually didn't get a chance to read that for like 3 days. So just to give you some feedback into how that works from our end.
Yep, for sure. Yep.
Right.
All right. Well, if everyone's okay, then
Yeah.
we can end this meeting.
Thanks, everybody.
All right. Thanks.
guys.
Thank you.
Thank you. See you.
Stay
Thank
safe.
you.